In a recent conversation, Daniel Faucitt and I talked about the meaning of fitness for purpose or fit for purpose. What do we actually mean when we use that phrase? So the whole question about what fitness means, and in a sense, the real meaning behind that much misused phrase of the survival of the fittest. Because what we will do in a real world environment is we will map out what's known as a fitness landscape. How well something fits the particular purpose in each of its different variables. So what we're doing is we're mapping out that certain solutions are more fit than others in different conditions. A simple example is the methods that we would use for governance. If we look at something like the difference between Agile, Lean versus Six Sigma, they apply at very different types of environments. If we try to use Agile in a context that is highly stable and must be highly controlled, we're doing the wrong approach. Likewise, a very rigid waterfall type approach doesn't work well with something where we really don't know what's going on. The question then is, are the methods that we use fit for purpose? And we use a fitness landscape, a mapping, to tell us which approach fits better in different circumstances. The next catch is what I call variety weather, where the variables that we're using to map out the changes, the fitness, are themselves variable. So that we can have not so much a fitness landscape, but a fitness seascape, where things change over time. The fitness for something, the perfect fit for one condition, no longer applies when the conditions have moved to something else. So we can use tools such as scan about how close we are to real time versus the levels of uncertainty in the space. We can use tools like that to map out not only the uncertainty itself, but also the uncertainty about the uncertainty and the types of uncertainty that we're dealing with. The crucial point here is that in understanding fitness for purpose, we need to design for what changes as well as what doesn't. We need to design for uncertainty rather than pretend that the uncertainty doesn't exist.